喂，有没有声音？麦克风测试，麦克风测试，有没有声音？楼上有没有声音？もしもし。喂，麦克风测试，有声音吗？Hello。Hello。Hello，有声音吗？Hello。Hello。Hello，有没有声音？Hello，楼上 Hello，哎，楼上的 Hello，哎，有没有声音？哦，回我一下啦，拜托，我累。Hello，拜托几口嘞，回我一下。Hello，有没有声音？
我现在说话。
好，现在有声音吗？OK，
有清楚。
好，撤退。再见。我这边。
是李中南老师。李中南老师。
喂？啊，这样有声音吗？OK。
你要关电脑关？
我关了。断线，楼上就不要点这里。没有，随便了。他们也没有在点。但是今天是英文。好，再来。对。
Okay, it's about time. Okay. I would like to, I think we had a great honor to have Professor Asutoshi Kumar Singh to be here with us to talk about the subject of machine learning driven resource management and data security models for cloud environment. And Professor Singh got his PhD from the Indian Institute of Technology, and VHU. And he is one of the top universities in India. And he graduated from the electronic engineering. So original research area is in the verification, synthesis, design, and testing for electronic circuits. But later, he switched his research into the cloud computing, web technology, big data analytics. And Professor Singh, he was the chairman of the Department of Computer Applications, National Institute of Technology. And he, after he got his PhD, he went to the United Kingdom and joined the University of Bristol for postdoc. And also he went to the Japan and went to the Malaysia. So he has been many countries and collaborated with around 7 universities. And currently, he is the director of the Indian Institute of Information Technology. And that position is more like similar to the president of the university. And he's very tough to get that position. He's one out of around 200, maybe 60 person to get that position. And I think most maybe impressed is his academic record. He had published more than 380 journal or conference paper. Most of the journal papers are in the IEEE and Asian journals. So I think we had give him the very, very warmest welcome, Professor Singh.
Hello. Okay. Good afternoon, everyone. Today, we are going to talk about machine learning driven resource management and data security models for cloud environment. Something about me. I have worked in 7 universities so far in my career. More than 20 years experience, and currently 26 researchers are working with me, and travel more than 25 countries for academic and research assignment. Cloud computing is the environment where we have shared pool of IT infrastructure IT infrastructure in terms of hardware. That one we call infrastructure as a service. The second one, software, SaaS, SaaS, software as a service, and PaaS, platform as a service. So all these services we can share and access anywhere at a time. So anywhere we are calling because these resources are connected through internet. So even you have your mobile phone, and from your mobile phone you can access supercomputer which is located in somewhere geographically maybe 1,000 kilometers away from you, like California or other countries. In this case, the system works like this. This is the cloud data center, and these are users. It can be individual user or can be group user or organizations like business organizations, research organizations, government organizations, everything. You can access cloud data center through our internet connection. Like you may know that quantum computers are already in market. IBM has launched quantum computer. If you want to do some experiments on quantum computer, you can access, student version is already there. So they have some sample quantum computer they place at one place and given the access throughout the world. So you want to use, you can use. You can't buy because quantum computers are still in labs, it's very limited. But this kind of flexibility you can access because of cloud environment. There are some challenges. These are the regions we have to switch because it's on-demand services. On-demand self-services, whatever you want, you just pay the rent and you hire. Something like you want to use aircraft. You can't buy aircraft, but of course you can rent it. You can pay, you can buy the ticket, you can fly. But if you want to buy that flight, you need one or two lives to earn that money to buy one aircraft. Same thing is here. You rent it. So on-demand self-services. Whatever service you want, you can rent it and get it. Broad network access, resource pooling, measured services, outsource IT management and rapid elasticity. This point I want to highlight. For example, you develop a lab in your university. You need IT people to manage. Someone is going to install. If something happens, you have to go and repair. But for this case, no. All management is at cloud part. You don't have to worry because you are renting. There are several challenges with the cloud. Some of the challenges we have highlighted, but daily new challenges are coming in the picture. Researchers are doing research and saying that these kind of problems are there. Some of the challenges I have highlighted: resource distribution, load balancing, power consumption, carbon emission, secure workload processing, data security and privacy, network congestion, reliability, trust management, risk analysis and management, compliances. Some more, you can add it. When we go for some model, so in our research, our group, we are dealing some challenges, not all. So we have done up to here, resource distribution, load balancing, power consumption, up to here, reliability, trust management, risk analysis and compliances. Still it is not proposed any model from our side. If you see this diagram, in cloud data centers, what happened? Something like infrastructure. First, for IT you need hardware infrastructure. So for hardware, generally we keep servers, high speed servers we have, and that servers are connected together. People are renting either infrastructure as a service or software as a service or platform as a service. All three operations going to depend on infrastructure. So how to understand? Infrastructure means the hotel's ballroom. You go and you organize any party in hotels, there is a big area, that is ballroom. That one you can consider as a infrastructure as a service, the hardware part. After this, software as a service, decoration, that ballroom is decorated. That decoration you do, that is software as a service, like it's a food party, and the type of food, the quality of the food you serve, that is basically platform as a service. So for all these three, if you see the servers here, this is overload, because in this case CPU is 90% utilized, memory is 90% utilized. For these, another 1, 2, 3 is okay. 1, 2, 3 is okay. It's like average. But the fourth one is overload and the fifth one is underload. In this case, you can see unused resources. Because of this, what happened? Since the servers are consuming power, they need power. And because of the power, there is a carbon emission. If your server and computer are consuming more power, they are generating the heat also. If you go to your CPU, you can see the backside of the CPU, there is a heat generation. Because of that heat generation, huge carbon emission. It damages the environment. So, power consumption, you can see excess power consumption just because of this problem, overload and underload. Resource wastage, you can see here, you have CPU and memory, only 15% is used, 85% is wastage. This wastage consumes lot of cost because it's a huge infrastructure. Another is frequent VM migration. Because of this frequent VM migration, increased service level violation. Service level violation, service level agreement violation. Because once you rent cloud environment, you pay, so there is an agreement between you. You don't want downtime, you want 100% accessibility. And the last one is because of this performance degradation. this problem, this diagram is simple. We have 5 servers here. But to try to understand a case, nowadays IoT devices are very famous, Internet of Things. You know, currently 60 billion devices are connected together. 60 billion. And you can imagine per second how much data they are transferring. Whenever you Google your path, you walk, you just Google your restaurant, you Google your distance, your campus. Even one day, how many times you are Googling, searching. And because of that, thousands of servers are getting active at a time. And once they are active, they are going to consume power, they are going to emit carbon dioxide because the servers are active. So it's not only it's 5, but to get the problem, it's the million of servers are sitting here. So if you don't solve this overload and underload problem, you are going to get, these are the challenges. So for this, you have to predict, to manage. So there are 2 techniques we apply. The first technique is workload prediction and efficient resource management. So how we can say this management is clear? If this overload, some of the part you change to underload. So what happened? It become average. That management you can do. And then you can solve these issues. But for management, efficient resource management, you have to predict first. Because every kind of management depends on prediction. I want to do something tomorrow. So first I have to assume how much resource we need tomorrow. That tomorrow you can just change it in number of hours, number of minutes, number of seconds. Once I know that, after next second, how much resources I need, because millions of users are attacking same resource. So for that case, first we predict, and the second we manage efficiently. So for prediction, in short, prediction is very popular objective of human life. Everywhere you want to predict, like share market, election results, money market, what is going to happen tomorrow you want to predict. And generally, always prediction depends on historical data. Whenever you are going to predict what is going to happen tomorrow, so first you should know what happened today. So the past recall. And now everywhere we are applying artificial intelligence. Machine learning is the subset of artificial intelligence, because we can't rely on statistical models. We want machine generated tune. So in that case, most of the prediction models are using artificial intelligence. That artificial intelligence like machine learning approaches. So we apply machine learning, predict the value. Now machine learning is further categorized into 1, 2, 3, 4, 5 parts. This categorization we are proposing, maybe you can categorize 6 parts, 7 parts. So evolutionary learning, deep learning, hybrid learning, ensemble learning and quantum learning. these machine learning techniques has been used to predict workload in cloud environment. The last one is proposed by my group, our research group. Professor Lee is the part of that research group. So I will present here the quantum machine learning part. The second point is after prediction we have to manage efficiently, and always remember management is not only division. Out of 10 consider this is one infrastructure, 10 users are asking for this infrastructure. How you are going to distribute? Only one infrastructure is there. So the time wise you can define that first, second this guy, second, next second this, because it's rent. But it's not only number of requests divided by number of tools. It's something else. We have to see different kind of perspective for management. That perspective are application level, virtual machine level, physical machine level. Something like take an example. You want to book a ticket in flight, in airline. The concept is very simple. You log in, you put your passport detail and ticket is with you. Once you are on time, it's like first come and first service. This is the management. But it's not. If you are blacklisted from your country, if you have something like wrong track record, you are not going to get ticket. So the management is something like this. If I am going to worry about application level, so management formula is different. You can see the management like in your university. Someone is president, someone is dean, someone is professor, someone is assistant professor. You can't say that it's a human being, then management should be equal. So that kind of concept we have to apply here. So for this case, finally we found some research gap between workload prediction and resource management gap, and we get it. So for this, we are going to apply quantum machine learning, first part to predict the resources. So I'll try to explain this quantum machine learning in easier way. So whenever we do prediction, our objective is very clear. So many parameters we use, but I always tell that objective is very clear. We want to predict 100%. We want accuracy should be 100%. Means I predicted tomorrow 10, I should get 10. That is the best prediction. But generally it's not, because if prediction is 100% means whole world collapse. So for this, the workflow is we get workload from end user. This is the cloud data center. These are the users getting workload. So there is a workload repository. Repository means historical data. Every data center has some historical data. That data center is generated workload. This workload is normalized. Some kind of data sanitization. After that normalization, this particular data is trained, validate and test. So if you are applying machine learning, first of all you have to check out of 100% data, how many percent data you are going to train? 60%, 70%. Then validation bit less, then testing bit less. You can't test for all type of data, because if you start testing, you are going to kill your time. And this kind of concept is very traditional concept. You can go and ask a cook how to cook rice. So once they cook rice, they take 1 or 2 rice out and then they test it. Oh, rice is cooked or not. Not every rice you are going to check. And based on that, you proceed. So you can see the training data. This training data we have applied EQNN, evolutionary algorithm we have applied, and its quantum neural network, train, then if prediction model is okay, accuracy is okay, then retrain, and then finally we test it and predict some value. So this prediction is going back to this place. So the first part is data is learning here. After that, data is testing here, and then based on this testing data, we predict the load. So during learning, we apply training and validation both. Some places, this one, they bifurcate learning, validation and testing. But we claim something else. We claim that validation is the part of learning. So only do 2 parts. So this is our diagram. I'll just explain. Don't worry about the complexity of this diagram. It's very simple. Generally, all this neural network model, we have 3 layers: input layer, hidden layer and output layer. These 3 layers we have for neural network training. So in first layer, input layer, the data is sitting here. These are historical data. You can see n number of data. N can be anything like billion, million, 100, 500, whatever data set. So this one, input layer, first we convert into qubit neuron. This D is converted into qubit neurons. And for this conversion, different kind of mathematical operations are available. Quantum physics is very old concept. Before, I think 50s, 60s, 70s, lot of theoretical models were proposed. So just pick anyone from there. So the first point is qubit neurons, and then apply some weights. That weights up to you, because now the 0, this data was in the form of 0 and 1. Now we convert into the value can be anything between 0 and 1. Anything between 0 and 1. And for that, we have to define some kind of weights. After this, first, once we convert, then we have to do some kind of pre-processing. So let us see. Data pre-processing. In this case, the input value dr like this, normalize. So this is normalization. So in normalization, you can see what we are doing. It's very simple. This D, this particular D is subtracted by minimum value, divided by maximum and minimum. This kind of normalization, any type of equations you can apply here. So after this normalization, input layer, we just proceed at qubit generation. So for qubit generation, we have to go for rotational effect, because it is, if it is take x is 0, y is 1. So between this, it's 360 rotation gate we apply. So for this you can see this qubit theta is equal to pi by 2 multiplied by d. So what is pi by 2? Pi is, pi value know that 360 divided by 2 multiplied by particular data. So now the value is in the form of not 0 and 1. So this is qubit generation. After qubit generation, we go for hidden layer. So for hidden layer, what we do, we apply some kind of gate here, applying C0 gate. So for this again, I can tell you, C0 gate effect as a activation function. For training, we always have some kind of activation function. I am giving some tips to you. This place we apply C0 gate. C0 gate is quantum gate. You can apply something else. You can apply MCT gate, MCF gate, Fredkin gate, like different type of gates are there. So since this method was first proposed by us, it was a very big risk because people conversion was different. They wanted to convert bit into qubit by different method. This method was proposed by us. Therefore, we took limited risk. We took the simplest gate. Simplest gate is control not gate effect as a activation function. And after this its output layer, we did this C0 gate is applied as a sigmoid function. And using this, we got it final output and then prediction value we get it. So this model, when it was published, we modified and we went through this. In this model, what we are doing is, you can see, same thing. Training, this the data we are taking from history. Then this is Hadamard. So instead of C0 gate, we used Hadamard gate. Instead of evolutionary algorithm, we applied black hole theory. Something like you can apply genetic algorithm because you are going to train the data. Training the data is something like whatever algorithm you apply, you will be getting the same kind of concept. How you are training the people of your country. Something like kindergarten school student. I always give this example to my all student who is going to study neural network first. 10 students from Japan, their training is different. Therefore, they understand Japanese culture. Same student move to some other part like African country, the training is different. Therefore, they give different kind of things. So it's a training, how you are giving the algorithm. So from computer science student, I always say that you see the dream to develop an algorithm for training. Don't use existing one. You want to use existing one, so many data, training algorithm classifiers are there in GitHub, you can get the code. So after this, we applied black hole theory and Hadamard gate and we got some result. So for the result, the way I said, ultimate goal is our accuracy should be 100%. Other side I can say error should be less. So in this case you can see our prediction error is reduced by 89.87. So let me show one or two results for not many. This you can see. This is our EQNM. This yellow color. You can see yellow color is minimum. This is the NASA data set. From NASA data set, if you take the 5 minute only, because even in 5 minutes you have trillions of requests. So this is minimum. If you go for 60 minutes, still 60 minutes you can see. For 60 minutes still it is minimum, EQNM. For 5, this another Saskatchewan, another data set is minimum. Rest, these are the other methods. And in this case you can see closer to actual value. You can see the black color is original value, actual value, black, and red color is proposed value. You can see red and black are matching very close. They are going together, red and black, but others you can see different. So after this, several parameters are there, like root mean, square error, so many things with parameters are there, but all parameters are basically made for each other. You can do normalization. You can see here the prediction accuracy is improved by 22.83 to 75% 1-2. And this 75% 1-2 is a very big number. Even if you can improve accuracy by 5%, 10%, it's a miracle basically in the cloud computing environment. The outcome of this work is we have 3 papers related to this. This we got recently. We applied bio-inspired virtual machine placement towards sustainable cloud resource management, published latest in 2023. This paper was 21, we published the first work in Quantum 21. We started work since 2019. So after working 2 years continuously, submitting and rejecting all these things, so 2021, and this another paper is still under review. So these are some outcome. Another part of our lecture is, our seminar is data security. So whenever we go for cloud, the major challenge is data security, because the data has been sifted from your laptop, your desktop, your machine to the distributed environment, to the cloud environment. Something like Facebook. You uploaded your picture on Facebook. You don't know what Facebook is going to do with your picture, because it is sifted from local machine to global machine. So you want to make sure that your data is secure. For example, your credit card. Your credit card has 9 digits, 0 to 9, 10 digits. The back side of the credit card you have 3 digits. You are doing shopping online. Data is transferred. How to make sure that your data is secure? So this kind of challenges you can see. In 2021, roughly around fraud complaints are 576,365 fraud complaints. Huge number. And you can see the security as a top concern. 55% people, they are just worrying about the security part. They don't care about other things. Money, you take it, never mind. Services is slow, is okay. And especially for some applications, example, banking sector. You don't want to lose money at any cost. You are okay, you take 5 minutes, 10 minutes, half an hour, I don't care. So for this, it's a bottleneck situation. Means, bottleneck problem means today you propose one model, next day what happened? Criminals got a counter method, they crack it, again you propose new one, again something like this. So for the data security is divided into 2 parts. The first part is privacy. and second part is breach detection. Privacy means it's like you get the data you see, but you can't use. Something like, it's a kind of like I'm traveling, but you don't know where I'm going. That is privacy. The security is superset of privacy. But security says that even anywhere you are traveling is okay, but you should be secure. So in that case, like you see privacy, cryptography techniques. It's like always confusion. Which one is having more importance, security or privacy? So the best answer is security is the superset of privacy. You want to secure the data, first time you have to make private the data. After this private something happened, then again we have some methods to detect. That is security. So in this, many methods are there: cryptography, access control, differential privacy, anonymization, and breach detection. So this part has two categories: proactive and reactive. If the data is breached, data is stolen, then you can detect. Method reactive. Proactive means make sure that data is not going to detect. That something like research, you proposed a model to fix a problem. Another researcher say that you propose a model to avoid the problem. So this is a kind of like proactive approach. We try to avoid the problem. Not like after getting the problem, you are ready to fix it. And that Russian researchers, they found it, TRIZ technology. TRIZ. You can just Google and get it. The TRIZ concept say that you don't wait for the problem to come, then you apply your algorithm to fix. It's no. You just do all the algorithm method you apply to check the problem to avoid at any cost. Anyway, so these are the literature review. So for this, we have one framework. This framework is look difficult, but it's very simple. Let us start. I am the data owner. Like YouTube video you upload, everyone want to watch, because if someone watch, you get more money. But some type of data you want to upload, make sure that no one see. So the data owner is sitting here at local machine. This paper was written before 7 years. So that time our group was not so good to develop the diagram nicely, but still we publish in IEEE transaction. So at local machine, data owner is there. This data owner owns particular data D. So before shifting, you do encryption, something like local encryption. You go to your house, in your house what you do, some almirah you lock, after that you come out, you lock your house also. So it's something like this. You have almirah, you lock. Some encryption technology is there, you lock, and then after that you pass to cloud service provider, say that I want to keep my data to the cloud. So this cloud service provider is very smart. Before locking your data to here, this encrypted data is basically applied machine learning to add the noise. The noise adding is something like, if you have 100-page book and you add 100 pages more. You become 200 pages. So if book is lost somewhere else, no one can identify which 100 page is original. So data is encrypted. After this, noise is added. So this cloud service provider, after encryption, add the noise, then only it stores. So users are there because, therefore I said, users are asking not only infrastructure, software, application. Users, they don't need your hardware, they need some data to do some kind of work. So once the user asks the data here, this user, this place, so ask from CSP, and this place, this fellow is middleman. So this CSP what do? Pass the data, transfer, and then key also transfer. Key is transfer. And then it is with noise data. If this data is this user side, after opening, user was so smart because data is in his hand, key is there, that fellow leaked the data. Leak the data to third party. Then we apply detection mechanism and we find who is the guilty user. Therefore, in this system, we don't trust user. User is untrusted entity. Owner is trusted entity. And CSP, cloud service provider, is, it's not like trusted or untrusted, it's semi-trusted. He has some curiosity. He's curious to know what is inside the data. So for this, he's curious, so you can't do because data is encrypted here. So after this we apply, you can see here, the data owner side, all the process we do, data is here, apply encrypted algorithm. After this encrypted algorithm, we just make it to CSP, and then user side, you get the keys and we pass it. This is for data encryption. After this, data owner, this diagram is quite interesting. You can see. Data owner is data encrypted. After that, there is a noise, encrypted noise, and this place noise is added. And then data is processed, apply machine learning technique, and then only it is going to pass to the data center. This is our data classification. Then for leaking the data, leaker detection. Once the data is leaked, what to do? For this, the model is statistical. Somehow we felt this place we can do more work, more research required. Distribution means once the data is given to you, and if it is leaked, it means you have leaked. That's the concept. So statistical model we apply and we proceed, and we got very interesting result. You can see improvement up to 103%, relative improvement up to detection rate 151%, accuracy improved up to 86%, precision 96%, and this is overall comparison of the work. So this paper was published in 2020, but this is half a story. The biggest story is this model we modified, and this paper is under revision in top 2 journal of the world. Second top journal of the world, Transaction and Pattern Analysis and Machine Intelligence. This is the second number. The first number is nature electronics. So that base paper is under revision, and the comments are so simple. I am very confident we can crack the comment. And what we did, just in this we applied multiple control Toffoli. This quantum algorithm we applied. Quantum concept we applied for data security and we cracked this. So the last phase of my talk is, how many minutes are there? Okay. The last concept is malicious user prediction. Malicious means who can leak the data, we have to predict. And for that, again we back to the quantum. We applied quantum algorithm to predict the user. So in this diagram you can see, we start from here. Someone is data owner, he has the data. And for that data, someone is asking. Who is asking? User is this side. User is this side. Just you send the request. But before request, we just say that user live information. Means who you are. So based on this user live information, we have user historical information. So we have the history for every user. If no history, new user, then we have different kind of treatment for the new user. But if it is existing user, then we have some historical information. But it's not that only deal with old user, we deal with new user also. So after this historical information we take, and based on that we model the behavior of user. Model the behavior of user. And this user attribute, final m number of attribute. So if m number of users are there, for this everyone has attributes, and this attribute is further moved to the quantum machine learning based malicious user unit here. In this case, we have input layer, hidden layer and output layer. So for input layer, again, for input layer, we have applied quantum machine learning. So for that, first user behavior is converted into qubit form. And that qubit form is, again we apply the training algorithm at hidden layer, and finally we get output. So first of all, some of the behavior I can just tell you. We have for user behavior modeling unit displays. User asks the data. So there are first two categories. User is known or unknown. Mathematically we have to define. Unknown means 0. If this is this, then known. Otherwise unknown. This is for historical data. Then yesterday during presentation, Professor Lee asked a question. I answer here. Then after that, frequently asking the data means one user is there. This user is asking the data frequently. Something like after 5 minutes this, then 10 minutes this. Even once we pass the data to user, we know that for analyzing this data he needs few days. But he asks again after 5 minutes. So it means something suspected. Next, type of request. Something like a professor is asking the data for criminal record. A healthcare person is asking the data for banking sector. So we have this kind of So like this different type of at least 25 attributes we have collected together and we combined all we combine. Some of the measure we have taken here, type of request inside, we just categorize. This one is frequently in this around 7 attributes, for this type of around 20, I think 12 or 13 requests we have for this, and historical data is single. After this we just go for data pre-processing, add input layer qubit generation, very simple, apply rotational effect, hidden layer we applied CNOT gate because we have introduced this method, we have right to use our own model. So you can see this place output layer, this is CNOT gate, CN, some places it is HN, this is our output layer, we get it, and finally we get very interesting result. And this is the first type of paper where before passing data to the user from cloud, we analyze the behavior of the cloud. And very interestingly, therefore I always say, knowledge is historically, like you see traditional, our people were so smart. Today new generation wants to put handphone in your hand, you search everything, you have answer everything, you feel you are smart, but it's not. The old time, 100 years, 200 years back, when people, they don't have tool, but still they were doing the same thing what we are doing today. Just technology has been changed. And that idea I got from one story when I was reading, that in one remote village, one old person was there and he was identifying the thief who is going to steal money from other houses. And what mechanism he was using? He was just sitting somewhere outside watching the people. If any new people enter in the village, he suspect. And then he just tried to identify what he is doing and all the things. That concept I applied here. So before asking, and interestingly you can see, the actual and our method is very close. This green color you can see, quantum 1. Actual and quantum 1 is very close. The rest machine learning technique we apply, even in this case, the idea was different and technique both were different. So in this case, other places you can see, very close. They are just like hanging each other. But blue color, this green color and black color is very close. Similarly, all the things we got it. So our precision, accuracy, recall and F measure 94, 90, 94 and 92.50 respectively. So we got very good result. Rest after that we got encouragement. Once this paper was accepted, we did some more changes, and in this what we did, first thing we attacked to the gate. Instead of CNOT gate we applied Pauli gate. You can see Pauli gate because Pauli gate is also quantum in nature. You can change the gate and see the effect, but the gate should be quantum in nature. So Pauli gate was quantum in nature, and then this user behavior model, some of the parameter we left in first paper because we couldn't strike. But when I was going to present somewhere else, then people asked, why you didn't consider this parameter? Then we considered that parameter, and for every parameter we need to justify mathematics, something like how to develop a mathematical model for my behavior. It's not very easy. You can't say that this person is good or bad. Have so many methods, so many parameters you apply, and then you calculate. So this model is still under review. So these are the results we got it. So you can see the outcome is sitting here. First paper is already published. For the second paper, since August 2022, more than 1 year, we are waiting. So that's from my presentation. The limitation of the work is, I can just say this, like quantum machine learning prediction model, single steps user behavior. That you can extend up to multi-step. That is, multi-step is possible. I don't want to disclose the idea how it is possible, because something like we are having this idea for future. But always as a student you should understand the difference between academic research and industry research. Academicians, we are doing research whatever we like. We are not industry people. We have generated the initial idea, published the paper in the market. Now industry people like banking sector, they want to use my algorithm. You read it, understand it and use it. But everything at the university level is not possible. So it can be extended up to multi-step. This model is so far offline. It's offline. That we can convert into online also. Immediate calculation is doable. Development of new methodology for data security with better performance we can do. These are some kind of, if you are doing or studying cloud environment, you should be very happy. Why this is not going to die? Because this region, top 5 research area in computer science. Whenever I say research area, I am very clear what I am saying, because your job is going to depend on research area. Why computer people are having great package in the world? Because daily research is going on. Why not civil engineers have more jobs in industry? Because architecture design has been fixed, nothing more. Even you change the civil engineering idea that your house can float, immediately you can see all the jobs in civil engineering. So you want to retain your industry job, you have to retain your research. So top 5 computer science research areas are using cloud environment, all using cloud environment. So you can see, you can go any top, you have to use the cloud. And if you are doing work in the cloud, you should be very happy. The second point is industry, academia and research center, they want to save money. Every industry, like nowadays, everywhere the point is cost cutting. Everywhere you move, cost cutting is there. You want to save. Something like your university, I can give the example. If they want to buy a supercomputer, they need few thousand $. They don't want. What they do, they just buy 10 personal computer in your room, give the internet and connect your system with supercomputer through cloud data center and pay the rent. So to save and capital and maximize revenue, you have to use. And the third case is emerging technology, IoT and cyber physical system. Nowadays, everywhere people are talking about Internet of Things, all electronics people, cyber physical system. And I also feel that in future you can see the concept of cyber physical system. The example is very simple. Your house and police station is connected together. So if something happened in your house, you don't have to go and lodge a complaint to the police. Automatically there will be a signal from your house to police station. Both are connected together. That kind of time is going to come. So whenever you use IoT and CPS, they are going to force to use cloud environment because they don't have the processing capacities. Our IoT is going to depend on small sensors, and that sensors are not having any capability. For example, your smartwatch. In your smartwatch, so many options you have. But every data of smartwatch is stored and processed at the cloud environment, not in your watch, because your watch is not having the capability to process and analyze the data. Even your mobile phone is okay, some data you can process, but these teeny devices are not having the capabilities, therefore forced to use cloud environment. And in beginning I gave you the example. Now 50 billion devices are connected together. 50 billion. Our world population is close to 8 billion. How many world population? I don't know. 10 billion? World population, I think 6 or 7. We have to check it. No, whole world.
80 or 70 billion.
8 or 7 billion. Yeah. So you can see, means one person has almost 5 times devices. They are connected and they are going to generate the data and all. Therefore, I am confident why cloud will never die. These are the regions. So these are the references. That's all from my side. If you have any question, I am happy to answer. Thank you.
That's wonderful talk to first.
Some question from the audiences. So, any question from audiences? Please.
Professor Singh, I have an interesting problem to ask you. In your opinion, if you have to give a priority to 3 kinds of technology, which are AI, cloud computing, and security. So, which one, in your opinion, which one is the most important? Is AI important than security, or security is more important than AI?
Okay, very good. AI is a kind of area. In my view, AI is a kind of tool. AI is a tool. You can apply for security, you can apply for defense, you can apply for agriculture, you can apply for healthcare. So artificial intelligence is a kind of tool. So you want to learn tool or you want to learn problem? If you want to learn problem, you have to go for the security. If you want to learn as a tool, you go for machine learning, artificial intelligence. So my view is, of course, it's the personal choice, which one you like. But industry-wise, industry used to go for something like artificial intelligence, because once they are expert for artificial intelligence, they can apply to security.
Any more questions? Okay. If not, let's Richard things home. Okay.
I can take picture of the students. Yeah. Just say last one. send to me.
Okay.
Yeah, just send. Drop me